Okay, in this video, I'm going to show you how to draw isobars. Iso is a root word meaning equal, and bar is a root word meaning pressure, so that we're going to draw lines of equal pressure. This is kind of like drawing contour lines, which would be lines of equal elevation. We're going to start with 1,000 millibars. You don't have to start with 1,000. That's just one place you can start. Once we have our isobars drawn, then you'll be able to identify the high and low pressure systems. Once you have your high and low pressure systems drawn, and we can look at the rest of the surface data, we can then identify fronts. And from that, we can then label our air masses. Okay, moving on to isobars. Again, I said we're going to start at 1,000 millibars. So we're going to take a look. Remember the numbers in the upper right-hand corner. We're going to look for numbers around 1,000. If we can't find anything at 1,000, we can find a number that's greater than 1,000 and a number that's less than 1,000. And we're going to draw our isobar line in between. You can think of it as a number line. I'm just going to draw to the side here. Oops. Remember in elementary school, if you had a number line on your desk, we'll say this is a 1, this is a 10. You can then estimate that an 8 would be about here. A 3 would be about there. So if this were a data point on our surface map and this was a data point on the surface map and I was drawing the number 3 line, I would estimate in between those 2 points. Remember our rule, if it is less than 1,000, you add a 10 on the front. If it's greater than 500, then you add a 9 in front. So this one I'm trying to look at here is greater than 5 or 500. So we're going to add a 5 on the front. A 10 on the front. 9. 9. And then we would move our decimal point. So that's 994 millibars. Now you don't have to go through and add all this, but if it makes it easier, you can. Here's one that is 1,000. 1,001.7, because that 0 was less than 5. So if it makes it easier to draw your isobar line, you can write these out. Remember, you can also double check yourself. Your pressure should always be around 1,000. Okay, so now it might be a little easier to find something greater than 1,000 and less than 1,000. So this is greater than 1,000 and this is less than 1,000. So I know my isobar line is going to go in between. Every time you draw your line, you always have to double check what point you're going through to make sure you're going in between the points. So again, you're always looking for one that's less than and greater than the line that you're drawing. Okay, so can I go this way? Can I continue my green line this way? The answer is no, because this is less than 1,000 and this is less than 1,000. So I can't go through there. So we have to find another spot. That's less than 1,000 and this is greater than 1,000. So before you just come down through here, see I'm going through these 2 points. You have to double check your work as you go. That's greater than 1,000 and this is less than 1,000. So yes, that does work. Less than 1,000, greater than 1,000, less than, greater than. Now when you're drawing your isobar lines, they're either going to do one of two things. They're either going to connect, most likely in a circle, or they're going to run off the page. And there we go. Now most likely my isobar line is not going to make a turn quite like that, so I'm going to sort of even it out there. Now we're going to draw our isobar lines every 4 millibars. So I'm going to draw 1,004 millibars. Or I can go down to 996. Let's go to 1,004. You can go either way. So now 1,004. So this here, that's 1,005, so that's greater than. I can use the line that I drew. The line that I drew here, remember, represents 1,000. It's always a good idea to label those. And I can use that as a reference point. I'm drawing 1,004. So go in between these two stations because this is 1,005, which is greater, 1,002, which is less than. I'm drawing 1,004. Okay, if you look, this is less than, so I cannot go through here. This is greater than, so I can't go through there. So it looks like it's just going to run off the page. Now we can't leave an open-ended line, so we have to finish our line over on this side. This should be 1,004. Now, so you don't always have to connect up here because I don't have any other data points here, so I don't know truly if that's going to curve quite like that. At this point, that was just an estimation. And it might go off the map there. Most likely it's going to wrap back around and connect, but again, I don't have a lot of data points, so I can't be sure. We're going to move on up to 1,008 millibars. So here's 1,009, that's greater than. There's 1,005, that's less than, because I'm doing 1,008. 1,008 is going to come really close to 1,007.5. And it's going to go off my map. Now let's go back towards our 1,000 millibar line and draw 996. Okay, 997 and 994, that's greater than and less than. There's a 97 and a 94, so I'm going to keep using this 994 data point. Double check as you go along, and it's going to make a complete circle. And we're done with the isobar lines. Now we're going to label our high and low pressure systems. Low pressure is always written in a red L, and a high pressure system is always written in a blue H. Usually your pressure systems are sort of bullseyed with a circle, so we can take a look at this circle and look at the pressure inside the number versus outside the numbers, or outside the circle. Inside, it looks like my numbers are lower. That's what makes it a low pressure system. Next, we're going to look and find our fronts. Our fronts are located around our low pressure systems. Remember, they tend to arc outwards from our low pressure system. Some key things we need to look for when identifying fronts. We need to identify fronts using obviously they're going to be near low pressure system. They're going to have precipitation. Even cold fronts are associated with thunderstorms. Warm fronts are associated with nimbostratus rain, which are your overall sort of rainy days. We need to look in a change in wind direction. So we're going to compare two stations next to each other and see if they change in a wind direction. And last, we're going to look for a change in temperature. And the change in temperature is going to help us identify whether it's a warm front or a cold front. Okay, let's take a look. Again, they usually go into the center of a low pressure system, so we can kind of look in this region. But if I look at two adjacent surface models, we can compare them. I see overcast, so that might be a sign. But if we look at our temperature really doesn't change very much, and our wind direction does not change very much. So most likely this is both part of the same air mass. If I look down here, I see some cloud cover down here, so that's an indication. Next, we're going to look for a change in wind direction. This wind's coming from the south. This wind's coming from the northwest. So that's definitely a change in wind direction. And a change in temperature over a short distance. So that's going to be our front. Now last, we have to identify, is it a warm front or a cold front? Remember, our low pressure systems rotate counterclockwise. So I'm going to draw an arrow here to help us remember. It's going to go counterclockwise around the low pressure systems and in towards the center. So if I'm taking a look again at these two stations, and if I were to temporarily draw my front line here, and it moves this direction, what's going to happen to this surface temperature? Is it going to get warmer or colder as this air moves this direction? Well, this is colder, so that means my air is going to get colder. That's going to represent a cold front. Remember, your triangles always point to the direction it's moving towards. And in the northern hemisphere, they move counterclockwise in a low pressure system. Okay, let's double check to make sure there are no more fronts. I see some cloud cover over here, so that might indicate a front region. So next, let's look for a change in wind direction. Looks like this is all kind of coming from the south. This is coming from the northeast. So bingo, we found our next front. Let's double check the temperature. 55, 60. So that's pretty close to each other in terms of distance, and the temperature changes. So again, my front's moving this direction. So will this 55-degree temperature get warmer or colder as the front passes? It's going to get warmer. So that's going to be my warm front location. And the last thing we need to do is label our air masses. Remember, CP means continental polar, MT means maritime tropical, etc. So if we take a look over here, our winds are coming from the northwest, and they're cold, and it's fairly dry. That's going to be our CP air mass. Next, let's look in this region. Here our winds are coming from the south, and we have some precipitation. Now that could be because of this front. We have high dew points. So that's going to be a maritime tropical air mass. Coming in from the northeast up here. And we got some clouds, but again, that could be that's affected by the warm front coming in. But winds coming from the northeast, most likely that's a maritime polar air mass. And that is it for this weather map.